Welcome back. We're now going to look at ionic equations and specifically net ionic equations. And if you remember, when you have something that's dissolved in water, that's soluble in water, you have a solution. And that solution, you can't see anything. It's dissolved in the water. The ions are all broken apart. But if you were to have two solutions that you mix together, those ions could recombine in different ways, and the resultant product may or may not be soluble itself. If it's soluble, it stays just the way it was. Nothing changes. Nothing looks different. But if you form a compound that's insoluble in water, then it will fall out of the solution. It will either come out as a precipitate and fall to the bottom of the test tube, or usually bubble out as a gas. So first thing we need to do is anticipate what could be the possible reactants if you recombine these ions differently. Right now we, in this example, have nitrate joined with barium and sulfate joined with lithium, but if we were to switch those partners around, you could possibly have barium and sulfate together and lithium and nitrate together. So those would be your, if you do have a reaction in this would be your possible products. Now let's balance this equation. To balance this equation, we've got two nitrates on the left, so we're going to have to make two nitrates and two lithiums on the right, so we now have a balanced equation. And from here now I can anticipate, or I can predict, whether or not these two products will be soluble or insoluble. From your cheat sheet, you know that sulfates are soluble for the most part, but there are some exceptions, and barium happens to be one of the exceptions. So barium sulfate on the right of this equation is now a solid. It forms as a solid, and it doesn't stay as ions. It now forms as a solid, and it's heavier than the water, and it falls out of the water, falls to the bottom of the test tube as a precipitate. The nitrates are all soluble, so lithium nitrate is soluble, so it remains as ions floating around in the water. So now you have a solid, barium sulfate's a solid, and everything else is aqueous. So the next step of this is to anticipate what is my ionic equation. Break everything into ions except what you've made into a solid. So in this case, I've got barium, I've got two nitrate ions, I've got two lithium ions, one sulfate ion. On the right side of the equation, I have barium sulfate, which is a solid, leave it alone. And then I have two lithium ions and two nitrate ions. This is called the ionic equation, where you break everything else into ions. So ionic equation is you're halfway done when you get to the ionic equation. Now you're looking for ions that do not participate in the reaction. So if you have an ion that's on both sides of the reaction, those are called spectator ions. So the first one that I see nitrate that's on both sides of the reaction. That's a spectator ion. I also see lithiums, which are on both sides of the reaction. That's a spectator ion. And everything else is participating in the reaction. Because if my product is barium sulfate, what makes up barium sulfate? Well, barium is in barium sulfate and sulfate is in barium sulfate, so that's all that's left. So at the end, after you've scratched out all of the spectator ions, you're now looking specifically for whatever's left. So I have barium, which is 2+, I have sulfate, which is 2-, those are ions, and it forms a solid precipitate, barium sulfate. So this is my answer, this is what I have formed as a product. And this is called the net ionic equation. And it's whatever's left over at the end of all of the spectators, everything that doesn't react. So whatever's left over is your net ionic equation. Watch this as much as you need it, and I hope it helps you. Thank you.